All right, hey everyone. Today is September 9th, 2020, and we've got the CI/CD demos meeting for the APAC group, and Amy's going to kick us off. So go ahead and give us this demo.
Oh no, me first. Okay.
Yeah.
Let's see. Let me share my screen. Share screen. All right. So I don't have too much to show, but I can talk about kind of what we're working towards because this is still sort of in progress. So we want to get some user metrics for Auto DevOps CI platform target. Right now we support AWS deployments. We're adding Fargate, ECS, other things like that. We want to know who is using them and how many people are using them. And we want to see trends in that data as well. So the tool that we have for data visualization of this sort at GitLab currently is Periscope. And you can sort of expose a table to Periscope, and then you can see that in Periscope. So we wanted to be able to see this CI variable key right here in Periscope. Unfortunately, that CI variables table is encrypted. So you can't just expose it to Periscope, right? And if you could, or I guess you could, but it would be a security issue if you did, right? So we had to sort of like find a workaround for this. And this is what we've got at the moment. So there's going to be a new table, and that is simply going to have a recorded at timestamp, a platform target value, which is the value of this CI variable, and then a roll up so that we have the count of those variables, right? And this is user input, and it is only encrypted because of the way the encryption is implemented, which is that all of those variables are encrypted, right? It doesn't need to be encrypted, so it's safe security-wise. You can see the comment I have here to pull that out into a unencrypted context. So we're going to have a worker that's going to sort of like do this daily so that we can get the trends. And one interesting thing that happened as I was working on this is I had to get some clarification from the data team about how Periscope works because I hadn't used it before. But initially, I was operating on this mental model 1 here, where I was going to sort of like blow away all the data in that table and then push new data to the table with the variable, AWS Fargate, ECS, whatever, and the count, right? And that we would be able to see the trends because there would be some sort of push or pull event to Periscope. And you would see that data in Periscope, right? You would see, this trending up or this trending down or whatever like that. Found out that is not exactly how Periscope works. So here's mental model 2, which is how it does work, in the sense that this transition from the GitLab database to the Periscope webpage, that is a wholesale replacement of what exists in the Periscope webpage. So if you want to see trends in that data, there has to be trends in the GitLab database itself that can be then represented in the data visualization. So we had to go back and add this recorded at column here for that. Yeah, so that will get us all of the metrics for GitLab.com, right? It'll also collect metrics for self-managed instances, but we don't have access to self-managed instances. So there's a follow-up issue to sort of deal with that. We're going to have to somehow get that data and push it over. And I think Telemetry is the tool we would use for that. That's still in the sort of like proof of concept. We know we need to do it, but we haven't really started implementing it yet sort of phase. So I'm a little bit less sure about how that's going to shake out in the end. I think there's a new tool called Snowplow that we might be able to leverage for that, but I'm not sure if it handles the transport from the self-managed instances to our data repository, wherever that may live. So yeah, any questions?
Yeah, I have some.
Yeah.
Do you know that the variables can actually be defined in few other tables too, and not just in CI variables?
No.
Yeah, that's that's something fun I found when I was working. So because we have different levels where you can define them, we have also different tables. These
Okay.
are like the most common. That is the project level, and you can have it defined as a group variable or as a pipeline variable, and eventually you can have
I
it in
think
the
I've seen
YAML.
that.
So you
Yeah.
may have to check all these other tables too and collect in some old accounts, because people may have like, I'm not sure, is it applicable for this specific variable for auto demo?
Right.
Like, does
Right.
it make
Yeah.
sense to have it at group level, but it's not stopping people to have it at like pipeline level or anything else?
Yeah. I'll have to see. I'll have to investigate then. That's a good
Yeah.
point as to how this
Because in
is
the worst
used.
case,
Yeah.
that may be just the subset of all
Yeah.
the
It
usage.
even if even if it's only valid for this particular CI variable model right here, we might want to capture it for all the other contexts as well, just to find out if the users are misusing it. That was another concern, like what happens if like this platform target value is like the empty string, or if it's like the letter 1 or whatever, which actually in production, there is a instance of it just being 1. I don't know why, but because this is user metrics, right? We want to capture all of those. We don't want to like filter them out, because we want to know if the user is misusing the feature, how they're misusing it, and how many people are misusing it, and could potentially like investigate that. So okay, cool.
And like, I'm not sure, but have you tried to have that data from just querying the variables table and counting instead of storing it? But yeah, that's different
Yeah,
thing.
yeah,
I'll take a look at this later, because it looks interesting from a database perspective.
cool.
Okay, thank you.
Any other questions?
One quick question. So
Yep.
you mentioned something about telemetry for self-managed instances. Is that, do you know how that relates to the usage ping, or is that
Yeah, I've
that?
heard of those like usage ping, telemetry,
Okay.
snowplow, but I haven't actually like investigated how any of those work.
Okay. Okay. The I know a little bit about the usage ping, because I think my one commit in GitLab is for that. But there
Nice.
is a class somewhere that that has basically it's this job that runs. I'm not sure if it's like weekly or something like that.
Yeah, it's once a week.
Is it once a week? Okay. And it's just this Ruby class that goes and like gets a bunch of metrics and throws it into a JSON or object, and then sends it somewhere, sends it to us. And so from there you can go and like add those in. So it's pretty straightforward to do that. I'm not sure how the data model would work with like what you're trying to structure here, but there's a lot of patterns in there for how people are doing that. So that might be a way to start getting some data in there before some of the newer telemetry stuff is rolled out, if you want to. So
yeah, we might do that. I know Ari is super excited about getting this done as soon as possible, so
yeah,
we might go with that.
Okay,
Cool.
All right, any other questions? No. All right, so we have a double header from Kraz today. So we'll start with the generic package repository.
Okay. So we are working on adding a new type of package registry called generic, and it's basically generic. You can push any random file under some package with name and a version, and then download it. And that's usually something that package will work on, but we started because we want to use it for release generation, so that you can be able to generate your release assets, then push them somewhere if you don't have like where to push them right now, and then use the URLs in your when creating releases. And it's still work in progress. and I'm trying to keep it pretty simple for now. So basically, that's a project that doesn't have any packages right now. We'll need to do a front-end merge request to add generic here on the top as separate tab. And the way you upload is you just make a put request to the API and with your token. It supports either private access tokens or job tokens so that you can do it from a job. Then you pass the file as a body of the request, and that's the endpoint where you have like the project ID is here. Then you have the package name, package version, which I kept simple for now, just the major minor patch from same version because it's easier to validate. And if we decide to have a latest endpoint later, it's easier to sort in the database. And that's the file name. It's similar to what other packages are doing right now. This will actually, the actual upload will be accelerated in Workhorse. So we need to have a small change to GitLab Workhorse to add a new route. So this is the branch. So yeah, I'm basically adding another route that when Workhorse sees a route like this, it hijacks the request, uploads the package to like local disk or object storage if it's supported, and then it's passing the data for that file to Rails so that all this happens faster and Rails is not overloaded dealing with uploads. And let's try to actually upload something. Oh. Okay, this now failed because I don't have the private token as an environment variable in this tab. So let's try the other one. And this one says it's created. If we go back here, yeah, that's my awesome package version 1.0.0. And here is the file, which you can download. So yeah, that's basically it. I'm now working on the upload, what I just showed. It's in review, and then we'll have one more merge request for downloading because it doesn't make sense to just upload stuff if you can't fetch it, and that will be like the MVC we need for release generation. They'll probably need to be more work done to make it nicer, but that's the base of it. So that's for packages. Any questions so far?
Sorry.
Oh, go ahead.
I was going to ask a little bit about the UI here that you have, like the MyAwesome package v1. Like, is there plans for like integrating metadata relative to the package, like, you know, for like C++ specifically, like?
Oh yeah. So for C, we support the common package manager, and this is a generic UI we have for packages, and it just works. I haven't done any front-end work. It just works by adding the records to the database. But for all of these package types, we have a separate database tables to keep the metadata because it's different. And for example, for Conan, we have even maybe more than one table. And if I had a Conan package and you click on Conan, then you'll see all the additional stuff around this. And it's same for Maven and NPM and NuGet and the Python one.
Cool.
Yeah, but this is like the basic. We have it like a kind of like skeleton for package registries. And if you don't have any metadata, it just works like in my case. And I don't think we'll have anything specific for generic packages, but yeah, who knows. But yeah, I think we support the common registry, like it's fully supported or almost fully supported.
So my question was, we have a we have a section where we show releases, right?
Yeah.
Is this intended to integrate with that in some way, or is this intended to be just completely separate?
I think it will be separate, and in releases, when you create a release, you can grab the, you can use the download URL for this file, and then just use it as a asset link when you're creating the release. So they'll be separate, because some people may actually, for example, just when I started working on this, someone was asking on Slack that one of the Linux distros, I think it was Arch Linux, has a pretty simple package like system, and it's just a zip file, and you just need to be able to push it somewhere and download it. So then this generic packages can be used as a package registry for Arch Linux. So it's basically like a whatever. It's kind of like S3. You can push and pull stuff from it, and it has some versions, and that's it. So yeah, at least to answer your question, I don't think we'll integrate them now, but we'll just use the links from the package registry as a release asset links.
Okay, that makes sense. This is like a really cool building block, because I can see a lot of just sort of like with a generic thing like this, you can build on top of it in all sorts of.
Yeah, that's one of the in the issue in the Epic we have. That's one of the reasons we have it, because our use case is just one of them, and you can use it as a substitute for other registries that we don't support yet, or for something else. And it's offered, the same feature is being offered by the competition like JFrog and Nexus. They have like some sort of like just raw packages or generic packages. Kind of.
Yeah, cool. Okay.
Awesome. Okay.
And
so now, yeah.
I was gonna say no. I think one of the most requested features with releases is attaching binaries or things that are related to that release. And by having this, we can just create even though it's just a link that is going to point to this package registry, but at least it's going to be somewhere. And then in your release, you can just click and download, and it's all good.
Yeah, sometimes you just want a place on the internet where you can put a file. That's all you need.
Yeah, because if you're like not like very big organization and you're using GitLab, because everything's in there, and that's kind of a missing piece now. You need to set up like S3 bucket or any other storage to just put some binaries that you need later on.
Cool.
Okay, and yeah, so last time, any more questions on packages? Should we move to the...
Go right ahead.
Can I use it?
Not yet, because I have to ship to my laptop. Yeah, I was hoping to get it in 13.4, but we may probably have some of it or behind feature flag. So in the next release, we'll probably be able to. So that means we'll have it on .com sooner than later. Yeah. So last time I showed you how we define secrets that are stored in Vault so that we can use them in our CI jobs, but we didn't have the runner work completed last month. So I was pretending that I'm runner and was making API requests to fetch the jobs. We have that now, and it was merged, so it will be released to our shared runners fleet probably later today or tomorrow. So I'm gonna demo how this works now with the runner, but the runner is running, it's private runner running locally on my laptop and registered for my project on .com. And it's that kind of cool, because if I'm using an actual shared runner, then I need a Vault server that can be accessible, that can be accessed on the internet from the shared runners. And I really didn't want to deal with installing and configuring Vault server. So the Vault server is also running locally on my laptop. And this is, I think that's a use case that will be very, very compelling to our enterprise customers. This means that they can have their Vault and their private runners in their private network, and the secrets go from Vault to the runners, and they never even touch GitLab, or they don't even need network connectivity with GitLab. So I'll just start. Okay, let me first. So we have some secrets in my vault. Just they're mounted under using different paths and same secrets engine. And I'll start that runner here. And if we run a pipeline, for the branch that has secrets defined, like you can see that it's being picked up, I think. Yeah, it's picked up by the runner. And you can see here that it got the secret configuration from GitLab, and it fetched the secrets from Vault, and it's exposing them as a CI variables of type file, which means that the actual value is written in a temporary file, and the environment variable is holding the path to this file. And here is the actual content of the secrets. And that will be just a GitLab Premium feature. And you can actually do this now, but manually. You have to like manually log in in your job, log into Vault, fetch the secrets, and then do something with them. So it's like a nice addition to make it easier to use. Any question on this one?
Can you go over the configuration for this one more time? I know you talked about it last time, but just to sort of restate it.
So that's actually, I have 3 different secrets so that I can show the different forms of the syntax. So, okay, basically we start with adding a new section, a new keyword for YAML, which is secrets. And that's the way for each job to explicitly define the secrets that it needs, because that's different from CI variables, which are like all variables are always provided to every job. That it doesn't matter, does it need it or not. And the Vault keyword here is like the provider you are going to use, because we have planned to add more providers in the future. But for now we have just Vault. I guess the next one will be we'll try to separate secrets from CI variables, and we have like some sort of internal GitLab provider so people can use, and we can I don't know, maybe in the future add AWS KMS and the Google's equivalent for that. So just Vault was the most required now. And that's like the simplest form of the syntax, where we assume a lot of defaults. This one is the same, but you specify specific path for the secrets engine if it's mounted on a custom path. And that is the detailed form where you can provide any of the details we need and not use any defaults. And that will be useful in the future when we add support for more of the Vault's secrets engine.
Is there is this default to like localhost and there's like a host key or something? Like if you're setting this up in a network?
Yeah, I'll show you this one. I forgot about it. So this we'll have in the future we'll have a UI under settings CI/CD where you can define where is your Vault server. Like it's basically the URL, the role, and the path. But for now, as for an MVC, you define these as CI variables.
Okay.
And if I don't have this defined, the job will fail with. I can actually show you this. I have one of this when I was testing. I think it's this one. So this is the same job but run without those variables. And you see it say failed because secrets provider cannot be found.
Got it.
So yeah, so that's like our MVC, and we have an issue to create a UI for this. So we even plan to be able to have more than one vote provider if your organization is that big that you have more than one vote for different teams and all that.
Cool. All right. Nice.
That's it.
Any other questions? All right, Jaime, you're up next.
All right, let me share my screen. Okay, so I just wanted to give a quick overview of what we've been working on Pages recently and how this is helping moving into like the cloud native and moving into Kubernetes, especially for GitLab.com. It's like a big pusher for us. So this is this blueprint is something that Gregor started working on, and I think this got merged already. It basically explains how Pages works right now, what are we doing to improve the work. There's a big epic that I linked in the agenda that links to a bunch of other epics if anyone is interested. But yeah, so just like as an overview, how Pages is working right now and how we integrate with GitLab. So basically, when anyone pushes a project, a Pages project to using the job on the CI configuration, it basically goes to GitLab Rails, and then Rails pushes it to a share file system, to a network file system. That then GitLab Pages can actually connect to it and grab the configuration and read all the files from there. Now, this is like one of the biggest, it's a big blocker for moving to Kubernetes, because all of the work that other people have done, I arrived a bit late to the party, but what I understand is like, this NFS is just not scalable, and it's not like a good way to just move into Kubernetes. So the idea is to try to decouple from this NFS dependency. And the idea with the new architecture is like, for the users, nothing will change. They will still deploy the pages, and they wouldn't see anything. It would just go to GitLab. And the idea is that GitLab will push it to object storage instead of pushing it to NFS. And then GitLab Pages, the daemon will read the configuration from the API from GitLab, and then the API will just tell you, okay, so this is in a zip file that lives in object storage, and just go and fetch it. And it just, for the visitor, for users checking the web page, they wouldn't see, this is all hidden, right? But it's going to be working much better, and it'll allow going into this cloud native architecture. There's a bit of a blog post that details like how this API is working, how GitLab Pages on the go side is doing a bunch of things. If anyone is interested in there. What I wanted to show here in the architecture. So basically what we have done so far is this bit, reading the configuration from the API. What is still work in progress is storing the content in object storage and actually reading from object storage. So that's, I don't want to say dates because we don't know when this is going to be ready, but we've been working towards that. Even this changing the configuration mechanism from the API, which means reading from this bit here. It's done for GitLab.com. For self-managed instances, users need to opt in. So we're trying to make this process a bit smoother, and we're trying to make it default for everyone in the near future.
Hey, Jaime, are you showing a graph on the screen or a sketch?
Yes, you're not seeing anything?
Yeah, I think I'm seeing the epic still. Is that just me, or is everyone else seeing that too?
Huh.
I feel like maybe I'm a little going crazy.
How about now? Is it still the Epic?
Yeah, it's still the Epic. That's so weird.
Let me reshare.
Yeah. Oh yeah.
Okay.
How about now?
Yeah, that looks better.
Oh, sorry, I'm talking to myself.
No, this is a classic demo problems, right?
Yeah. So what I was talking about is this dotted line here, reading the configuration from the API. That's what's done right now for GitLab.com when we're trying to move for self-managed instances. I'll show you before this, before going into this. When GitLab pages started, what happened is it had to look through all the projects that existed for that instance of GitLab, and it'll read the configuration into memory, right? So for GitLab.com, we had over 140,000 projects or something like that. And at some point in time last year, it would take over 20 minutes just for a node of GitLab pages to be ready. So, you know, we had people from SRE and everywhere like, hey, why is this taking so long? I can roll out this very quickly. So that was one of the motives to go into this API configuration down here. And I'll show you the code a little bit. Can you see the code screen? Or is it still the?
Yeah.
Yeah, okay. So basically what was happening on the GitLab daemon, sorry, pages daemon, we have this infinite loop that is watching for that configuration files. And it has this function, the read groups, that's basically just looking for this config.json file inside the NFS and loading that into memory. And this happened every minute. So it means that every minute it'll try to loop through all the files and update if there were any changes, right? So, but this process itself, in the last count, it was taking about 5 minutes. So that means we will just be spawning these routines or threads to be updating the configuration. It would just be super inefficient, right? Some side effects is like the configuration not being updated. People will be deploying something and then they would still be seeing like all configurations, or maybe enabling access control on your project wouldn't be super quick because it'll take some time for this configuration to make it into the daemon. So yes, it wasn't the best. What we've done with the API here is now say, okay, if we have this new flag, we call this the domain configuration source. And depending on that, on what you said is, we either start, we just use the API as GitLab, or we start the disk. And this new process is what would make it super slow. This is what started that Go routine and say, watch for configuration changes. The changes for self-managed is people still need to opt in to say they need to just go and say GitLab. The idea is to make it easier to transition and say, okay, give the auto option. So if the instance already has access to the GitLab API, just start using the API instead of using disk. And I will show you a bit of a couple of graphs on when we deploy this to GitLab.com. This is source domain configuration from the GitLab API for .com in production. There's a few graphs, the most significant graphs that I could see. Before the deployment on this left side, before 9 o'clock, you can see there's a lot of load. And that's pretty much all those routines trying to load the configuration all the time. Here, the CPU usage as well, like there's a noticeable, decrease in this computing power needed here. And then at the bottom is this node network utilization. You see it negative there because it's like reads, sending and receiving data. The negative is the receiving data that we're getting, and it's like a lot of things, right? Because every time we're reading this configuration, there's network traffic coming into the pages daemon. And then after the deployment, you can see it's like very minimal. I have a dashboard here from that date. It has a lot of more interesting metrics, but like, yeah, so as you can see, this little improvement, it looks like a little improvement. It has a very big impact. And yeah, it's kind of like what we've been working on. And the next stage is actually removing this NFS dependency from pages and serving from object storage, which is, we have help from a lot of people. This is pretty good. And yeah, it's a great collaboration effort to get this over the line. Hopefully it's gonna be there soon. Any questions?
Yeah, this is such a big deal. I know this is like been a work in progress for going on a couple of years at this point. So, I don't know if you saw this metric, Jaime, but around like the network activity. This was shared in a Slack thread somewhere, but basically we're like the data transfer between like nodes within, so like costs associated with it, but based on like server traffic and network traffic. When this process changed, we went from transferring 15 terabytes a day for pages down to 200 gigs per day, which is like a crazy difference. So you can just see like the level of efficiency that changed with this rollout. And this, like the graphs kind of show this too. So really cool.
Yeah, that's awesome. I saw something on the GitLab pages channel, but I didn't see that big drop in data flow.
Yeah, someone shared that with me and I was like, wow, that's like 90, 98, 99% drop in traffic.
Yeah, that's awesome.
What are the spikes on the right side? Are they normal or do we know? After the rollout.
Yeah, I don't know right now. Like, I guess we would need to see like a more updated graph and see if this is still happening. This one says
it's a specific pages node instance.
It's one of the nodes, and it's just a CPU usage. My guess, if I had to guess right now, it's probably how we're caching the configuration.
Mm-hmm.
And because there's a bug in there that we make like 6-7 calls to the same function over and over for every single request. So yeah, we have that there to improve sometime in the future. That's my guess, but I guess
okay.
This was right after the deployment, right? We will need to see this over time.
Still happening.
Yeah. So the one, I think this question came up a while ago and I wasn't sure the answer. So the idea then on the next iteration of this is we take that deployment as like a zip file and we don't put it on NFS anymore. We put it in object storage. Are we sort of like extracting that zip on first request to the site, or do we do like sort of a pre-extraction of that zip, or like how does that zip turn into a site that I can browse in my browser?
Yeah, so the idea is to just move the artifact as a zip from so the content is pushed to the artifacts as object storage. And when that hits the rail side, the idea is to copy the zip file exactly like that, as it is. Now the processing job that uploads that to the artifact storage does some analysis of the zip, just to check for dead links and that it's not a zip bomb and things like that. So that pre-processing is there. On the pages side, what we're trying to do is we're just gonna get a URL from object storage, and the idea is to have a long-live connection for that request, and we're gonna pre-process the zip file, put it into like a map that we can just access, directly, and that'll give us like the offsets of where does the file that you're looking for lives in the zip file. Because yeah, it's a bit of like when I was learning and reading all about this, the zip file stores like an index sort of like of where all the files are in the archive, and then we can just access them directly.
Oh, that's really interesting. So you don't have to like fully extract the zip file. You just need to know the map of where everything's at in the file.
Yeah.
That's super cool. I had no idea you could do that.
We still need to like, on the first load, if we don't have them in memory, we need to go through, iterate over all the files, validate that there are not, symlinks that don't exist or things like that. And it'll put them into memory. And then in subsequent requests, when we just want to open or serve a file directly, we'll know where it is, and then we'll just read that piece of memory.
Interesting. Okay. And then like that mapping is just like, that's going to be in memory in the pages daemon then.
Yep, that's right.
Okay. Okay.
I have a bit of code, but it's not working yet. That's not this branch. I don't know where I am. Yeah, I didn't prepare for that, but
yeah,
the idea,
okay.
The idea is that like, opening this super cool long connection and knowing where the file exists, and then just accessing super quick.
That's awesome. Cool.
And I think the idea is once we have this working, in the future we may look for making the cache shared and not in memory for each page's node, but like put it in Redis or somewhere else so that it's persisted between reboots and shared between the nodes. But that's like for the next iteration.
That's like the next iteration.
Yeah, that would make a lot of sense because then you can be a little more efficient with the storage, and then if nodes go down and reboot, they don't have to recache that.
Yeah. But I guess it will be configurable because not every one, like it will work for GitLab com, but for smaller self-managed instances, they'll be probably fine and like that. So we'll see.
Yeah. Okay.
Or we may even find it's not needed, though I'm not very hoping much for that. Pretty much we need to know like how fast it is, and then look at do we need to make it faster or it's good enough.
How do you either of you know how many nodes we run for pages in production right now?
8. I think it's 8
okay.
for .com. Yeah.
Okay. Nice.
Yeah, there's 8 in there.
Okay.
I'll share this dashboard on the agenda, so you can play around with those metrics. We also have some more metrics, but we don't have a dashboard for it. That's something I wanted to do and spend some time, but I'm not very good with these graphs and understanding how they work.
It's a whole other art.
Yes.
Nice. Awesome. All right. Any other questions, anyone? All right. Well, then thanks for demoing, everybody. Thanks for coming. Leave your feedback in the issue. And if there's ways that we can improve this, any ideas you have, either throw it in there or let me know directly. I always want to look for ways to make this better. So, all right. Have a good rest of your day. Thanks.
Bye.
Thank you.